Hey guys, this is lesson 10.3, and what we're going to learn is how to find common bases in exponential expressions and equations. So the first thing we're going to do is just practice that thing that we've learned, about the power rule. So here's a few examples. So we have 2 to the third power to the x power. When I have a power raised to another power, I can simply just multiply them. So this would be 2 to the power of 3x. The reason we're doing this is to prep for the thing we're really going to learn in this lesson, which again is finding common bases. But this is an important thing that we need to go over first. So the next one says 3 to the second power, all raised to the 4x power. So again, I'm just going to multiply the powers. 3 to the power of 2 times 4x would be 3 to the power of 8x. Okay, for C, I have 5 to the negative first power. Just to recall, what that really is 1 over 5. I don't need to change it to 1 over 5, but just pointing that out. So now, again, if I want to raise a power to a power, I'm going to multiply the powers. Be careful now, because this portion is a binomial, it's 2 terms. So I'm multiplying the negative 1 to the 3x and the negative 7. So I need to make sure I put parentheses. So I get negative 3x plus 7. And it's 5 to the negative 3x plus 7 power. For D, the last one, again, this right here is a binomial, so I need to make sure that I distribute. So now I have 4 to the power of negative 3 times 1 minus x squared. And if I distribute that 3, I have 4 to the power of negative 3 plus x squared. Also notice that the expression we now have as the exponent, this is a quadratic. That's going to come up as well. Okay, so now let's get to the meat of this lesson, which again is finding common bases in exponential equations. So we're going to do a few of these examples. So to start, we have 2 to the x power equals 16. So you might know this off the top of your head. You might know that 2 to the 4th power equals 16. Sometimes we just know them by looking at them. And also sometimes when the exponent is an integer, it's much easier. For B, same thing. 3 to the x power equals 27. You might know 3 to the 3rd power is 27. Because again, the exponent is an integer. The method that we're going to learn today is helpful when this might not be an integer. Okay? So what we're going to do is we're going to rewrite both sides of this equation, or maybe just one side of the equation, so that they both have the same bases. On the left side, 2 is the base. On the right side, 16 is the base. Whenever we write common bases, what we're really doing is we can't make a small number bigger. We can only make a big number rewritten as a smaller number to some power. So I can't make the 2 into 16. This is a common misconception. A lot of people want to say, oh, let's just multiply this by 8. That doesn't work because the 2 has an exponent. So I can't just multiply the base by something else. The only thing I can do is I can rewrite 16 as 2 to some power. So 2 to the x is going to stay the same. And 16 I can rewrite as 2 to the 4th power. So now, as long as the bases are the same, the exponents are equal. Let's do the same thing for B. So we have 3 to the x equals 27. Okay, well I can't make the 3 into a bigger number, so I can't make the 3 into 27 by multiplying by 9. That's not going to work. A lot of people are going to want to do this. I can't do that because this 3 is a base of an exponent and has that exponent of x there. What I can do is I can try to make 27, I can try to rewrite it as 3 to some power. Okay, well I can write 27 as 3 to the 3rd power. Since these bases are the same, x equals 3. Okay, we're going to try 2 more that are going to be a little bit more in depth than these 2. So they're not going to be ones that we can generally just do like this. They're going to be ones that we're going to have to use this method of common bases for. Okay, stay with me, last two. So I have 5 to the x power equals 1 over 25. So what I'm going to do is I'm going to make them have the same base. So I'm going to change the right side of the equation so it has the same base as the left. I know 1 over 25 is technically smaller than 5. However, the number 25 can be expressed as 5 to some power. Right? The number 25 can be expressed as 5 squared. And since that 5 squared is on the bottom of the fraction, we can bring it to the top by making the exponent negative. Now that both sides have the same base, x equals negative 2. On the other side, we have 16 and 4. Now, the reason this is a little bit trickier is because it's not 4 to what power equals 16. That would be easy, right? That'd be 2. But it's 16 to what power equals 4. You might know the answer, but we're going to practice using common bases. So we're going to make both sides have the same base. I can't make 4 into 16 because I can't make a number bigger. Well, I can make a number bigger, but for the purpose of finding common bases, you don't want to try to make numbers bigger. You want to try to make them smaller or the same. So I'm going to try to make the 16 have the same base as the 4. So 16 can be rewritten as 4 squared, and it has that exponent already. Now the bases are the same. I can combine these by multiplying. And this 4 has a power of 1. So I could figure out what x is by saying 2x equals 1 and solving for x. Okay guys, that's all for now. We're going to keep practicing this tomorrow and have a good day.